Yeah. So we want to talk a little about ratio and then proportion. I'll start with this here. What's a ratio? Right? Basically, a ratio is a relationship comparing two or more similar quantities, right? And what I mean here is that, okay, let's say you're talking about uh, some money being shared. Let's just say as an example, right? So if $1,000 uh, is to be shared, let me use the two. Let me use two. Let me start with just two, right? 2%. 2%. And one got or I'm using present tense here or future tense, and then one will get, let me say one will get $600 while the other will get $400. Right? So let's take this. So the ratio of what one person will get in comparison to the other can be written like this. 400, put two dots here, and then we put 600 here, right? So that's a ratio in which this money is shared, 400 to 600. Now, we wouldn't leave, usually a ratio is unitless, right? A ratio is unitless, so we don't normally have any signs in there. Shouldn't have those signs. This will break down to 400 to 600. Another thing we do is we reduce it just like you reduce fraction. So I'm seeing that I can divide by 200, so I'll end up with 2 to 3. Will that be okay? Yeah. 2 to 3. So the ratio of how this money was shared is 2 to 3. The ratio of how the money is to be shared is, and we're going to get that, right? 2 to 3. So 2 to 3, that's a relationship. And it's actually kind of tell you the relative weighting of one share of the money to the other, right? You can have it in, you don't have to have just 2 parts to the ratio. You can actually have more than 2, right? So maybe if we take the same situation, and let's say we're sharing, all right, the same $1,000. I'm not gonna write out all the words in. And let's say we're sharing the $1,000 in the ratio, all right? Let's say 100 to 200 to, how much is that thing? Let's say 700, right? So if we were to break this down, it would be 1 to 2 to 7. This is also a ratio, right? You don't have to have just 2 parts. 1 to 2. You can have 1 to 2 to 7. You can have any number of parts there, right? Good. So um, that's a little definition here of what we mean when we talk about ratio, right? When you have two ratios that are equal, right? As you can sense, right? Let's say you know back at that previous one that we had, previous one. I think we had what 400 to 700, which breaks down not 400, 600, right? We have 2 to 3, right? Now this ratio can be written as a fraction, right? It can be written as a fraction. You can write 400 to 600 is equal to 2 over 3, right? These are two equal ratios. Equal ratio, right? I just want to give me a second, please. I just want to do something quickly. Just give me 1 second, right? We pause the recording. Yeah. So that's a simple example here to illustrate how you can express, you know, a couple of similar quantities, right? It doesn't have to be two sets of quantities, right? You can actually have 3, 4, any number of them. And we did see an example of 3, right? I mean, when you have a situation where you have 3 of them or 4 of them, it might be difficult to write them as fractions and so, right? Because, you know, fractions only have numerators and denominators. So at least you see, though, how when you have two quantities, two quantities, how you can actually reduce them, and as well as how you can write them as fractions, right? And there's some in the exercises you can actually watch and see how they actually, you know, do the comparison, do the reduction, and so on, right? Next, we want to talk about that other word. When we talk about proportional, we put a word here, proportion. Proportion. What do we mean by that now? Right? So what I really mean, and there's a little definition given here that, and again, when you speak of proportion, it's another relationship, right? It's another relationship. And we can say that two quantities are in proportion when corresponding pairs of values are in the same ratio. Now, what are we talking about? Let's take an example, you know. So let's say you're talking about you're buying something from the shop, you know. 1 pen costs, let's say $100. 2 pens cost $200. And then you can go on and on. All right, let's say, all right, 3 pens cost $300. Now, what you're seeing here, right? You have one quantity, number of pens over here. And then over here, you have cost of pen, right? So if you were to look at these numbers, 1, 2, 3, 100, 200, 300, do you see that, you know, that there's some kind of similar ratios going on? I mean, let me take one of them. Let's say, all right, 1 to 2, right? Let's take 1 pen to 2 pens. Isn't it true that you see, okay, 100 to 200? The ratio is similar, right? So if you were to compare the number of pens, you will see that there is also a similar relationship or a similar ratio for the cost. right? Similar if you were to put 1 to 2 to 3, right? You'll have what? 100 to 200 to 300, right? So notice they are in the same ratio, and therefore you can say that they are in proportion. Right? It makes sense, right? It makes sense. The number of pens that you buy, well, the cost of them will be in proportion to how many you buy, right? You buy 1 pen, it's going to be 200. One would think that, well, okay, you buy 2 pens, you're going to have to pay 200. If you buy 3 pens, you'll have to pay 300, of course, in the real world. Sometimes people say you buy 2, get 1 free, and all kind of thing. That, forget that, those situations, right? You're talking about, well, okay, in reality, if you were to, if 1 pen for $100, 3 pens should cost $300, right? So notice the ratio of the number of pens is also the same as the ratio. Because if you were to break this down, you will get that, right? Because the ratios are the same, then we can say that the quantity, these two quantities, right? Number of pens and cost of pens are in proportion, right? I don't know if you get that. You get a little understanding here. You think you get that? Give me some feedback.
Yes, sir.
Good. So you will hear something called proportional parts. Proportional parts. I want to focus on the parts now, right? So, and okay, you might have a situation like this. This is the example I was giving in the notes I sent you, right? If $25,000 is to be divided among two portions in the ratio 2 to 3, right? How much will each person receive, right? Good. So there are various ways you can solve this problem, right? There are various ways. But I'll show you one way is that where you calculate what we call proportional parts. So here, they have to have this money in a way that when you compare, all right, 2 to 3, and you compare how much money this one has, right, in dollars, compared to how much this one has in dollars. In other words, if you take those two amounts of money and break it down to its lowest form, you must get 2 to 3, right? You must get 2 to 3. Good. So there are various ways of doing it. So we're going to talk about it, right? Good. So how do we do this? Well, what we'll do first, we'll calculate what we call how much is one proportional part, right? So the ratio the money is to be shared is 2 to 3. So what we're seeing here is there are 2 plus 3, which is 5 proportional parts. Proportional parts, right? In other words, this money has to be shared into like 5 parts, you know? So one proportional part is going to be equal to the $25,000 divided by 5, right? Which is going to give us $5,000, right? So the person receiving two parts will receive 2 multiplied by 5,000 baht, right? Which is 10,000 baht. And the person receiving 3 parts will receive uh, 3 multiplied by 5,000, 15,000, right? And indeed, if you were to take these numbers, right? What are these numbers? If you were to take 10,000 and 15,000, and you were to break them down into smaller parts, divide everything by uh, let me go with 1,000 parts. You get 10 to 15, break it down by 5. Oh, if you break it down by 5,000, if you do this in divide by 5,000, you get 2. And you break this down, you divide it by 5,000, you get 3, right? So, yes, the money is shared in the ratio 2 to 3. Is that clear? Simple to you?
Excuse me, sir.
Uh-huh.
Is there another way you can solve this getting an answer? Because I
That's
did it
what I'm
the
saying.
way
I did one. I'm going to show you another. I'm just asking if this is okay.
Yes, sir.
Good. So let's do another one. So okay, another way. So we just said that okay, there are 5 proportional parts. So the first person received 2 out of the 5 proportional parts. So how much will he get? 2/5 multiplied by 25,000, and that should give you your 10,000. Right? So one person who is supposed to receive the 2 parts out of the 5 parts, right? 2 out of the 5, you write it as a fraction, will receive 10,000. And similarly, the person who is going to receive 3 out of the 5 proportional parts, you do it 3/5 multiplied by 25,000, and you will get 15,000. Right? One person is going to get 10,000, the other one is going to get 15,000. And the one with the 2 proportional parts will get 10,000. The one with the 3 out of the 5 proportional parts will get 15,000. Right? So that's an alternative way of looking at the same problem. Tell me if you're following. Is this hard? Easy to follow? You know?
Yes, sir. It's okay to follow.
Good. So next we want to look at something called, and of course there are lots of twists to these problems, right? I don't want to cover every one of them. Sometimes the problems will have various twists, right? And you have to know how to handle the twists, right? Let me probably do an example of what I'm talking about. Let me look for one that is tricky. I'm looking in the notes, one of those questions. Uh, All right, look at this one. Let me cut it from the notes. Let me cut it from the notes. And I'll bring it over. Every night I'm working here, there's a frog who thinks that the mouse pointer, cursor, it thinks that it's a mosquito or something. And it's always jumping on it. Yeah, look at this one. They say a sum of money was to be shared among 3 persons. ABC, right? They didn't give them names. And the money is to be shared in a ratio 3 to 2 to 5. So they say if C received, oh, notice that they didn't tell you how much money is to be shared, right? They're asking you that. But they give you a clue. So they're telling you that, okay, the C person or the person C will receive $420 more than B. And you are to use that information to determine the sum of money shared, right? You want to know what's going on here, right? C is receiving $420 more than B. So if you watch here, C is receiving 5 proportional parts, while B is receiving 2 proportional parts. So how many proportional parts is C receiving more than B? How many? C is receiving 5, B is receiving 2. So how many proportional parts is C receiving more than B? Tell me.
3.
3, yes. So what we are seeing from the information, C is, oh, I need to write, I don't know why this is writing so small. Oh, okay. One second. C is receiving 3 parts. I'm going to drop the word proportional parts. It's a long word to write out every time. Is receiving 3 parts more than B, right? So in other words, and notice that, you know, okay, those 3 proportional parts corresponds to 420, right? So we can conclude that 3 parts equal to 420, right? We follow that? From this, you can now calculate how much is 1 part, right? Therefore, 1 part is going to be equal to 420 divided by 3, which is, can somebody help me there? Huh? 14,
140.
140. But in all, there are how many proportional parts? Total money shared equal how many parts? 10,
10.
right? 10 parts. So that will be equal to 10 multiplied by 140, which is $1,400.
5
Right? So you see how the problems can come and call for reasoning, right? You will call for some reasoning on your part. Not all of them will be very straightforward. And there are many more in the exercises, right? I'm gonna give you some as a little for tutorial questions next week, right? And we're going to try them out during the tutorial session, right? And then you learn some marks at the same time. So wasn't this one, wouldn't you say call for a little bit of reasoning? Hmm? And get more feedback from you. Good. So now we want to talk a little about something called direct proportion. Direct proportion. And again, the notes tells us that two quantities are in direct proportion if they increase or decrease, doesn't have to be increased, by a constant multiplying or implying. Right? What do I mean here? Just like how I have just now, I had a case 1 pen costs $100, 2 pens cost $200, 3 pens cost $300. This is a good example of direct proportion in that when I double the number of pens, the price is doubled. When I triple the number of pens, the price is tripled. Right? So both quantities, right? If this one multiplies by 2, this one multiplies by 2. That's a constant multiplier, right? If this one multiplies by 3, then this one multiplies by 3. Right? So that's a good example of direct proportion. Right? Good. So let's take an example. I'm going to borrow an example again from the notes. Right? Good. So they're telling us here, I'm noticing the notes. I'm noticing like the notes, they kind of jumble up the notes a little. The pages. I wonder what happened. Something wrong with the notes. All right. Great. I hope you aren't misled when you do your calculation. Yes. So they're saying here a car travels 180 km on 6 liters of petrol. How many liters of petrol will be needed to complete a journey of 540 km? Right? So our assumption here is that the ratio of the amount of petrol used is directly proportional. That's our assumption, right? Or the ratio of petrol used is actually directly proportional to the amount of distance the number of km that the car travels. That's our assumption, right? So in other words, all right, let me just say, right? If 1 liter of petrol takes the car, maybe it's a little bigger. Too big. Let me raise this back and write it back. It fits on the line. So our assumption here is that, okay, if 1 liter of petrol takes the car, let's say X km, we don't know that. Then 2 liter of petrol will take the car to X km. Tell me if you agree. Also, 3 liters of petrol will take the car 3x km, right? Tell me if you agree. 1 liter takes it X, then 2 liter will take it 2x, right? So when you double how much gas is used, the distance doubles, right? We're assuming that there's a direct relationship between the ratio of the petrol as against the ratio of the what do you call it? The distance traveled, right? So if you multiply by 3, this will multiply by 3 as well. X becomes 3x, right? 3x. Good. So we're going to use that idea, right? We're going to use that idea. So there are several methods we can use to obtain the answer, right? And we're going to do a couple of them. So one method, and it's very popular in the textbook, is what we refer to as the unitary method, right? Where you find, like, okay, remember that thing where you find one proportional part, and then you calculate if it's 2, 5, 10 proportional part for the other part of the ratio. Yeah, we can use that method here as well. So here we are saying that, okay, we're using that method, right? 6 liters. Okay, I think I need to write that the other way around. 180 km uses 6 liters, right? So here they're asking you how much petrol is needed for 540 km. So what we'll do, we'll figure out how much petrol is needed for 1 km, right? So 1 km uses 6 liters over 180, right? Good. Therefore, 540 km will use 6 over 180 multiplied by 540, right? Which will give you what? You'll have to do that in a calculator. Somebody help me. Oh my, I don't have my calculator with me. Somebody do it for me.
Right, 18.
18 there, 18 liters, right? Yes. As a matter of fact, this quantity here, 6 liter over the 180 km, will actually tell you how much liters per km, right? This machine or this car is operating under, right? Yeah. So therefore, 18 liters of petrol will take us the 540 km. So this is the unitary method. They tell you that 180 km uses 6 liters. Therefore, you find how much 1 km uses. Right? You divide throughout by 180, right? By 180 by 180, you get 1. 6 divided by 180. Well, we haven't worked out that number, right? We left it like that. But you can reduce it if you would like. And the reasoning then is that if you take this one and you multiply it by 540 to get 540, then you should take this 6 over 1 and also multiply it by 540, right? What you do to one side, you do to the other side. Remember? That's the whole idea behind direct proportion. I'll show you another approach now. I'll erase this, right? Because I want to work right here. So we said that, okay, when you're dealing with direct proportion, the ratio of the quantities has like a constant multiplier. Therefore, if I were to take, okay, 180 km over 540, that should be equal to 6 liters over, well, let's call this X. We don't know X, right? Right? X liters. Let's go with X liters. So we'll drop all these units, right? Drop them. So we have a relationship here, 180 to 540. That's the ratio of the distances. It's supposed to be equal to the ratio of the amount of fuel used, right? So we can now cross multiply, right? We take this, we multiply over there. We take this and we multiply there, and you have 180x equals 6 multiplied by 540. X then is going to be 6 multiplied by 540 divided by 180. And that should give us, what was the answer? I cannot remember. Anybody write down the answer or multiply this back for me? 6 by 540 divided by 180.
Eighteen.
How much? 14?
Sorry, 18.
18 liters, right? Yeah. So X then is 18 liters. So this is another approach where you use the whole idea that the ratio of the distances should be equal to the ratio of the volume or the amount of petrol used, right? Because that's what direct proportion says. The ratios are the same, right? The ratio, these two ratio, the ratio of the distances and the ratio of the amount of petrol is equal in direct proportion. There is an even more complex, a little more algebraic approach, right? I'll show you that. I'll show you that still after you're taking notes or whatever you do. I'll show you. It's good for you to develop your brain to the extent where you can grasp algebra in particular, right? So let's take that one. So course, before I go into the actual solution, I want to show you a little bit of algebra, right? So when you're dealing with direct proportion, right? Now, if you say that if, let's say in this case, it's what? Amount of petrol, right? Or volume of petrol. Amount of petrol is directly proportional to distance traveled, right? Then let me use amount of petrol being, let me call it P, right? And distance traveled being D, just saying that, right? Petrol, we can use L too, we can use L, no problem, the petrol, because we're dealing with vehicles. Yeah. Then we can write, this is how you write it in algebra. P is proportional or directly proportional to D, right? And to eliminate this proportional sign or the proportionality sign, we need to introduce, because P is not equal to D, right? If you want to replace it with an equal sign, you have to put P equal KD. Now, K is called the constant of proportionality, right? A is called the constant of proportionality. And we need to evaluate it, right? We need to evaluate it. So how do we evaluate this then? I don't know if I can move this this way. This way. All right, good. So we have a relationship P is equal to KD. Now they give us some information where we can evaluate K, right? They tell us that 180 is equals to K times, sorry, not 180, 6, sorry. 6. 6 is equals to K multiplied by 180, right? So from that, K is equals to 6 over 180. You can reduce that if you want, right? You can reduce that to be 1 over 30, right? So our formula becomes, you can leave it at 6 over 180, but you can reduce it, right? So the relationship now becomes P equal 1 over 30 D, right? So here we have an algebraic relationship or like a formula now. So once we know the distance, we can calculate how much petrol is needed, right? So if D equals 540, then P equal 1 over 30 multiplied by 540, which should give us our 18 liters. So you see, this is a strictly algebraic approach where you come up with a relationship. Remember we did relations, functions, and graphs? Excuse me. So we come up with a relationship between P, the amount of petrol, and the distance traveled based on the information given. All right, so there are so many ways you can solve the same problem. Good. So I don't want to ask for an excuse again, because I seem to want some water to drink. Give me a second, right? Just give me a second. I'm going to pause it. Now we want to talk a little about uh, inverse proportion, right? Inverse proportion, or instead of the word inverse, you hear inverse. One second. Inverse. Sometimes you may see this indirect proportion. Inverse or indirect proportion. This is the word you hear more often. Inverse. Right? Now, what does that mean? So basically, what they're telling you is that okay, one quantity is inversely proportional to another quantity if when the force quantity is double the second quantity is half, right? Good. And the converse is true. If the second quantity is double, the first quantity is half. So and same, not just half the load. If the first quantity is tripled, right? The second quantity is divided by 3, right? So let me give you an example to bring this up. Too many words, right? So let's just say, right? 4 men can do a job in, let's say, 6 days, right? So 4 men can do a job in 6 days. Let's say the person who's hiring or who wants this job done, say, man, 6 days, that's too long, and it's got to be ready in 3 days. So 8 men, and if he wants a job done in 3 days now, 8 men can do the job in 3 days. So notice, when the number of men is doubled, the number of days is halved. Does this make sense? You can't have 4 men doing the job in 6 days. And if you double the number of men, they're taking 6 days again. No, that'll take less time. Right? So this is an example of an inverse proportion. When one is double, the other one is half. Right? There's a good example of that. And you see it a lot, especially in these kinds of job calculations. Sorry. Right? Let me see if I can find an example. I noticed something seemed to be wrong with our notes because for whatever reason, the examples don't follow the notes. The examples don't follow the notes that I gotta really look back at these notes I sent to you. Right? All right. I'll borrow one from you. Look at this one. Right? So they have one here. 12 men can sew 180 shorts in 5 days. How long will it take 15 men to sew the 108 shorts? So there are various ways we can look at this problem, and we'll do 2 of them, right? We're going to use the idea of inverse proportion using like a fraction or ratios, and then I'll show you a purely algebraic approach, right? So notice here, let me ask you a question. They said 12 men can sew 180 shorts in 5 days, right? Will 15 men take longer or less time? Which one?
Less.
It will take less time. You got more men, right? You got the work got done faster, right? Great. I like that answer, right? At least the reasoning is there. The idea that if you get more men to do the job, we got to do the work more fast. The bad thing is that, okay, just now we thought, well, if one is double, the other one is half. But think about it, we got 12 men here. We got 12 men here. And now we got 15 men. So it's not that, okay, the number of men are double, right? So it's not easy to say, well, all right, if the men were double, the time should be half. No, we just add on some men, right? We add on some men. So it's 12 here, 15 here. However, what we said about the relationship, right, is that there's an inverse relationship. So, all right, let's assume it was a direct relationship. So in other words, 12 over 15, if there was a direct relationship, we would have put 180 over x, right? If it was a direct relationship. However, this is not, it's not a direct relationship, right? No, the situation we're dealing with is an indirect or inverse relationship. Therefore, the ratio can't be related like this. 12 over 15 will be equal to x over 180. It has to be inverted, right? It has to be inverted. So from this relationship, no, not this one, not that one. They're not directly related, they're inversely related. So this ratio is going to be, well, you have to invert this one, right? So you're not putting the 180 here. Oh, sorry, not 180. 5. Oh man. Why didn't I? It's days. I get caught up with 180. What am I doing? Sorry. 5 gotta go here. 5 days. It's men and days. Like I want to sleep this afternoon. Yeah. 5 days. Oh gosh. So x over 5. Sorry. The 180 shorts is just like it's a task. The 180 don't play a role really in the calculation. It's just a job. Yeah. Why did I get caught up in this 180 business? Yeah. So it's x over 5. So now we have to solve for x, right? So if you were to cross multiply, you'll get leave this alone. You'll get 12 multiplied by 5 equal to 15x, right? The 12 by 5 is there. 60. So x then is going to be equal to x equals 60 divided by 50, which is 3 days, right? So the 15 man is going to take 3 days, right? So notice your relationship. If it was direct, you would have gotten 12 over 15 equal to 5 over x. But no, it's not a direct relationship. It's an inverse relationship. So this ratio, 12 over 15, must be equal to not 5 over x, but x over 5. Right? You have to invert one of them. So you play around with the numbers and you will get x equal 3. And indeed, 15 men will take 3 days to do the job. Takes to sew this 180 shorts. Why did I get carried away with that 180? You follow this one? It's a little complicated. Good. So what I'm gonna do, I'm gonna go back.
Sir, excuse me.
Uh-huh.
The 60 divided by the 15 is 4.
Oh, 4? Oh, gosh. Well, I just checking to see whether you all are with me. Yeah, sorry about that. Yeah, 4. So it's 4 days, not 3 days. Yeah, 4 days. Sorry. Yeah. Tonight something definitely is wrong with you. Yeah. Good observation. So let's use another approach, a more algebraic approach to solving the problem, right? So when there's an inverse relationship existing, right? Like, okay, in this case, let's say, all right, number of men, all right, let's call it n, is inversely related, right? Related to number of these, right? Number of men is inversely related to the number of these, right? We call it D, right? Or what do you see? I can write that the other way around. Number of D's. I use that as, let's say D. Is inversely related to the number of I put men here. I have a reason. N, use N, right? So because I want to make D the subject of the form. That's why I'm inverting the arrangement. What I had there just is not wrong. It's just that there's a reason. You will see why just. So what we could say then is that days, right, or D, the number of days, is related to the number of men by an inverse relationship, 1 over n. So you can read this as the number of days is inversely proportional to the number of men, right, needed for the job. Or if you want to say the number of days is directly proportional to 1 over n. That kind of misleading, I use the word directly proportional. So that's why the better way to read it would be the number of days, right, is inversely proportional to the number of men on the job, right? To eliminate this proportional sign to get an equal sign there, we have to insert a k, a constant of proportionality, into the equation, right? So this now, we can also write it like this, k over n, right? So D is equals to k over n. Now we have to find a value for this k, right? But they give us some information. They tell us that 12 men can do the job in 5 years. So if 12 men can do a job in 5 years, then 5 is equal to k over 12, right? Right? Are we good there? So from this, you're seeing that k would be equal to 5 multiplied by 12, which is 60. So we now have a relationship where K has a value now inside, right? So the relationship becomes this now. So the relationship becomes this. D is equals to 60 over N. Right? 60 over N. So you want to find out also this here, this relationship describes, but it gives you a formula now. Like you can, if you want to know how many days the job will take, you just plug in how many men you have on the job. Right? And that's what we can do now. So if N equal, and how much was N? 15 now, right? 15. Then D will be equal to 60 over 15, which is 4. So if you have 15 men on the job, it's going to take 4 days to finish. What do you say about this? This is a purely algebraic approach. When you start off with the relationship D is inversely proportional to N. That's how we write it. We replace this D equal K over N, and you have to find the value of K, given the piece of information that is given, right? Because they did tell you a piece of information that when N is 12, D was 5. So that can actually give you the value of K. Once you know the value of K, you can now write back. You can write back the relationship with K inside. So you got K as 60. So our relationship now becomes this. You know? And you know how a relationship goes. No matter what N is, you can calculate D. Right? So that's a case there of inverse proportion. Good. So what I want to do, I think this is enough for you this evening, right? I think this is enough for you for this evening. I want to pause here, and Thursday we'll take up a little bit on percentages. How do we calculate a percentage? You know, what one quantity is of another, right? Very related to ratios, but you're expressing it now as a percentage. And then we'll talk a little about averages, right? So I'll give you some time to consolidate and reconcile all that we did on ratio, proportion, direct proportion, inverse proportion, right? You get a chance to look at that. You can look at the notes. You can even try a couple. And come Wednesday, say, man, sorry, this one is funny, man. How you work out this one, you know? And we can actually try a couple, no problem, right? I know there's a girl that was saying, sorry, go for this one. And I think one of the listeners, he said, I didn't get this one. Could you do it, you know, go it over for us? So I'll give you some time to read the notes, because I only put them up this morning. I don't expect you to, you know, be able to read all those notes. So look up especially this part about ratio and proportion, right? So by Wednesday, we have that clear. And then we'll take up on Wednesday. We'll talk about percentage, and then we'll talk about what we call the arithmetic mean. I think that's, yes, the arithmetic mean or averages. We'll talk about how we calculate that and how that can be useful, you know, in everyday life. Good. So could we end there? I'm going to stop the recording.